Section 7.3, sample means. These notes are going to look a lot like the ones from 7.2 on sample proportions, because there's a formula for the mean and the standard deviation. The formula for the mean looks very similar. So it is this, the mean of the sampling distribution of x bar is equal to the population mean. So I want to write out the words for that, just so you know what that formula means. So the mean of the sampling distribution of x bars is equal to population mean. Very similar to proportions. Standard deviation, though, the formula looks quite a bit different, and which makes sense because in the standard deviation for proportions you have p, the population proportion. Well, we don't even have that when we're doing means. So the standard deviation of the sampling distribution of x bar is, it's the standard deviation of the population over the square root of the sample size n. So standard deviation x bar, this is given to you on your formula sheet, population standard deviation over the square root of n, and let me label these. This is the population standard deviation, population standard deviation, and this n is the sample size, just like before. Sample size, okay. But this standard deviation formula only works as long as the 10% condition is true. As long as, you guessed it, 10% condition true, meaning we don't sample larger than 10% of our population. Now, here's the thing. The distribution, if our population distribution is already normal, then when we take our samples, sample means, that distribution will also be normal. Okay? So it doesn't matter what our sample size is. So we can, so there's two cases. You can use a normal approximation. So for proportions, it was if np and n1 minus p are greater than 10. But we can use a normal approximation here if, number one, the population you sampled from in the first place was already normal. Population you sampled from was normal to begin with, or the central limit theorem. And if your sample size is big enough, then the distribution of sample means is going to be normal, even if the population that you sampled from was not normal. So the central limit theorem applies if sample size n greater than equal to